In this question, we will start off by drawing and labeling the two forces acting on the object. So let's look at the downwards weight acting on the landing craft and also an upwards thrust by the rocket that is pushing up on the landing craft. So that's the diagram of the forces. Next, in A part 2, we are to determine the mass of the aircraft. So we will use the idea of Newton's second law again to calculate what is the weight of the aircraft and then calculate out what's the mass of the aircraft. So we notice that in stage 1, if you look at stage 1 over here, it's told to us that the craft move with a constant speed. So there is an upwards thrust of a very big value acting on the landing craft, and at the same time there is a downwards weight as shown in your diagram, and this landing craft is moving downwards at a constant speed. This must mean that there's no acceleration and the landing craft has balanced forces acting on it by Newton's second law. So the balanced forces means that the downwards weight value will be the same value as the upward thrust, and that's the reason why we can immediately identify the value of the downwards weight to be the same as the value of the upwards thrust. So with this, we just need to use a formula that we have learned in the previous chapter. Weight equals to mass times the gravitational acceleration, and on the moon the G value is 1.6 Newton per kilogram as given in the question, and you can then figure out what is the mass of this object. Moving on, in part B, you are to calculate the acceleration during stage 2. Now, this becomes a standard second law question where on the right side of the equation, we have mass and acceleration. On the left side of the equation, we have resultant force, which we need to literally add up all the forces. So I have added up all the forces here, which is a weight and thrust. And even before we do all this, it's very important for us to define what is the positive direction. So I have decided to let downwards to be the positive direction for all my vectors in this question. So my weights will therefore be a downwards value over here, 24,000 Newton. It's acting downwards, so it is a positive force, and the thrust is acting upwards, and therefore my thrust value must be a negative value. Okay, so with this you can calculate out acceleration, and you got acceleration of negative 0.13 meter per second squared. This makes sense because the acceleration is in the negative direction. In this case, negative means upwards, and you increase the thrust, the upwards thrust, so that there is an upwards acceleration. Notice that this landing craft is falling down. It's trying to land, and it's moving down. And when it's moving down with upwards acceleration, this is why it slows down ultimately to a slower speed, and then it can land safely. In part C, why do landing crafts in the moon, why do they not use parachutes for the landing process? It doesn't really work. Parachute doesn't really work because parachute need air to provide the air resistance. So it works wonderfully on Earth when there's atmosphere and there's a lot of air. On the moon, there's like almost no air, and even when you deploy the parachute, there's no air pushing out on the parachute. Okay, so the parachute wouldn't slow down a falling object on the moon. So therefore, we must use the rocket thruster to provide this upwards thrust to provide an upwards acceleration, like how you have calculated in part B, for it to slow down until it can land safely.